In the previous video, we learned that if a to the power of x is equal to b, then we can rewrite this expression as x equals log base a of b. Okay? So right over here, as you can see, the exponent becomes on the left-hand side, and that's going to be the exponent right over here is going to be equal to log base a, because the a is the base here, then a is going to be the base here again. So log base a of b. So we can also write, for example, if we have like log base a of b is equal to x, then we can write this as, like, for example, we can write this as a to the power of x is equal to b. Okay? So in this expression, a is going to be the base again. And the exponent is going to be the value of this log function. Okay? Log base a of b is going to be the x. So a to the power of x is going to be equal to b right over here. So if this is given, then we are going to be using this information. Or if this is given, then we are going to be using this information. So let's do a few examples about this. Alright, so let's say 5 to the power of x minus 2 is equal to 3. So the exponent right over here is going to be equal to, so the exponent is x minus 2. X minus 2 is going to be equal to log base 5 of 3. Base 5 of 3. And then we could just take this negative 2 to the right hand side, or we can just add 2 to both sides. So let's add 2 to both sides. So negative 2 and positive 2 will be cancelled out. So we are going to be left with x equals log base 5 of 3 plus 2. So we can use our calculator and find the value of log base 5 of 3. And then we can just add 2 to that. Then we could find the value of x. But in terms of logarithms, so x equals log base 5 of 3 plus 2. Alright, let's do another example. So as you can see, we have 6 to the power of x minus 4 is equal to 10. So actually, I need to get an expression in the form of a to the power of x is equal to b, so that I'm going to be using x equals log base a of b. I'm going to be using this, okay? So now here I can move negative 4 to the right. So I can add 4 to both sides. I can add 4 to both sides to get 6 to the power of x. 6 to the power of x is equal to negative 4 and positive 4 will be cancelled out here. So 10 plus 4 will be 14. So now I have this form. So that means x is going to be equal to log base 6 of 14. So as you can see, 6 is the base. So here in this expression, 6 is going to be the base. And x is going to be equal to log base 6 of 14. So I'm going to write another example right over here. So let's write 7 to the power of x minus 5 is equal to 4. So we are going to solve this equation for x. Okay, we are going to find what x is equal to. So here 7 is the base and x minus 5 is the exponent. So I can write this expression as x minus 5 is equal to, the exponent is going to be equal to log base 7, because base is 7 in this expression. Base 7 of 4. And then we just move negative 5 to the right to get the x, or we can add 5 to both sides. So x is going to be right over here. Log base 7 of 4 plus 5. We are moving negative 5 to the right. Here is another example. 2 to the power of a plus 2 minus 3 is equal to 0. We're going to find the value of a here. So let's write a is equal to the question mark. So the information that we're going to use is when a to the power of x is equal to b, then log base a of b is equal to x, right? A to the power of x is equal to b. So I need to get that form, okay? I need to write my equation in this form. So please do not confuse this a with this a. They're not the same a's here. So we are going to find the value of a in this equation, okay? So let me just square this. Okay, so here we can move -3 to the right, or we can add 3 to both sides. So 2 to the power of a plus 2 is just going to be 3. This is the first step. And here my exponent is a plus 2. A plus 2 is going to be equal to log base 2 here. So log base 2 of 3. Log base 2 of 3. Just like in this case, okay? Here x is the exponent, so x becomes log base a of b. So here a plus 2, because a plus 2 is the exponent, a plus 2 is equal to log base 2 of 3. Then we just add -2 to both sides to get a. So a is going to be log base 2 of 3. The minus 2 will be the answer. This is a real number. If you use your calculator and find the value of log base 2 of 3, and then you just subtract 2 from that, you're going to find the value of a. So that's going to satisfy this equation. So let's do another example now. Alright, so let's find the value of x in this case. So first of all, we need to add 4 to both sides. Let's add 4 to both sides. So what we're going to get is 3 to the power of x divided by 2. -4 and positive will be cancelled out, so 0 plus 4 will be 4. So 3 to the power of x divided by 2 is equal to 4. So that means the exponent right over here is going to be, x divided by 2 is just going to be equal to log base 3 of 4. Log base 3 of 4. So now, in order to get the value of x, we multiply both sides by 2. So let's multiply both sides by 2. I'm going to multiply the left-hand side by 2 and right-hand side by 2. So here, 2 and 2 will be cancelled out. And on the left, I'm going to be left with x. X equals, I can change their places. So that's going to be 2 times log base 3 of 4. Okay, so x is going to be, I can also rewrite this as 2 in brackets log base 3 of 4. Actually here in this case we can just move this 2 right over here. We can write this as x equals log base 3 of 4 to the power of 2, but it's another lessons topic, okay? So you just need to know that the answer here, x is 2 times log base 3 of 4. All right. So I'm going to write another example. Okay, so in this case, as you can see, x plus 1 is equal to log base 4 of 16. I'm going to be using 2 ways of solutions for this example, okay? So here, the first one, we can write 4 to the power of x plus 1. 4 to the power of x plus 1 is equal to 16. And so I know that 16 is 4 to the power of 2. I know that 4 to the power of 2 is equal to 16. So x plus 1 must be 2 in this case, okay? So x plus 1 must be 2. So x plus 1 is going to be 2. So I can subtract 1 from both sides and I can get x equals 2 minus 1. X equals 1. This is the first way of solving this. And now, the second way of solving this, I can just find the value of log base 4 16. Log base 4 16. Let's say this is the question mark, let's say. So that means 4 to the power of question mark is equal to 16. Right? 16 is equal to 4 to the power of the question mark. So what is the question mark in this case? I know that 4 to the power of 2 is 16 because when I multiply 4 by itself twice, I will get 16. 4 times 4 is 16, so the question mark right over here is 2. I'm sorry. The question mark right over here is 2. So that means log base 4 of 16 is going to be 2, right? So that means x plus 1 is equal to log base 4 of 16, which is 2. I'm going to write 2. Then I can move positive 1 to the right hand side. That means x is just going to be 2 minus 1. So x is equal to 1. So there are 2 ways of solutions to this problem right over here. Okay. Let me copy another question. We are going to find the value of a in this equation. Log base 4 of a minus 1 is equal to 2. So the first step, we know that a minus 1 is going to be, in this case, 4 to the power of 2, right? 4 to the power of 2. So let's write a minus 1 is equal to 4 to the power of 2. So I know that 4 to the power of 2 is 4 times 4, which is 16. So a minus 1 is equal to 4 to the power of 2, 16. And a is going to be 16 plus 1. A is going to be 17. I'm adding 1 to both sides in order to get rid of the negative 1 here. So a is going to be 17. Alright, so in this example, we are going to find the value of a. Log base 5 of a plus 3 is equal to 3. So here, a plus 3 is going to be equal to 5 to the power of 3, right? 5 to the power of 3. So let's write the value of 5 to the power of 3 here. It's 5 times 5 times 5. So 5 times 5 is 25. And 25 times 5 will give us 125. So 125 is a plus 3. A plus 3 is 125. And I can subtract 3 from both sides. Then a is going to be 125 minus 3, 122. 122 is the answer for this problem. And this is going to be the last example. This is going to be the last. So log base 10 of x minus 3 is equal to 0. Okay, so let's find the value of x in this equation. First of all, I can add 3 to both sides in order to get the value of this expression. Okay, so add 3 to both sides. Log base 10 of x is just going to be 3, right? Or you can just move negative 3 to the right hand side and you can change the sign of negative 3. That's going to be positive 3. And so x is going to be right over here is 10 to the power of 3. 10 to the power of 3 will give us 10 to the power of 3 will give us x, right? So x is equal to 10 to the power of 3. And 10 to the power of 3 is 10 times 10 times 10. So that's going to give us 10 times 10 is 100. 100 times 10 is 1000. So x is 1000. X is 1000 is the solution for this equation.